Okay, on the previous video I showed you how to evaluate trig functions by drawing pictures, and it's good to do that when you're first starting out to really understand the different definitions of sine, cosine, and tangent, and so on. But now we're going to learn like some shortcuts because you want to save time when you're doing these. So there's a little acronym, ASTC. You see it in every trig textbook, and it's you can remember by thinking all students take calculus, or whatever acronym you want. And what it tells you is, well, the first letter is A, quadrant 1, quadrant 2 is C, quadrant 3 is T, and quadrant 4 is C. Alright, ASTC. And those letters correspond to whether trig functions are positive or negative in certain quadrants. So in quadrant 1, all trig functions are positive. So sine, cosine, tangent, cosecant, secant, and cotangent of any angle is going to be positive in quadrant 1. Okay? The S in quadrant 2 tells us that sine is going to be positive, but cosine and tangent are going to be negative for any angle that terminates in quadrant 2. So if you take the cosine of, say, 110 degrees, it's going to be negative. You take the sine of, like, negative 220, all right, it's going to be positive, okay? So, and it also works for the reciprocal. So cosecant would be positive, but secant and cotangent would be negative as well. All right, and then following that logic, in quadrant 3, tangent is going to be positive, so therefore cotangent is positive as well. But sine and cosine are negative, and secant and cosecant are negative of any angle terminating in quadrant 3. All right, sine, secant, and cosecant. All right, and then in quadrant 4, only cosine's positive. So sine negative, cosine positive, tangent negative. All right, cosecant negative, secant positive, cotangent negative. All right. So that's what this acronym means. So it takes half of the work out, and the other half we'll go over in the next slide. All right, but let's quickly look at why this happens. All right, well, remember, all of our trig functions are now based on definitions using y, r, and x. Okay, r is always going to be positive no matter what. Now in quadrant 1, x and y are both positive. So whether you do y over r, positive or positive, x over r, or y over x, you're going to get positive as long as your angle is in quadrant 1. Okay? Now, when we look at quadrant 2, okay, now y is positive, but x is negative. So sine is positive of an angle in quadrant 2 because it's y over r, positive over positive. Whereas the cosine of theta is equal to x over r, which is a negative over positive, which is negative. All right, so tangent negative because it's y over x, so it'd be plus over minus, which is a negative. Okay, so that logic you could follow to prove all of these. Like tangent of theta, if theta is in quadrant 3, well, tangent is equal to y over x. So if theta is in quadrant 3, the x coordinates and the y coordinates are negative, right? You can have a point like -3, -2. All right, if you divide those two, a negative over a negative gives us a positive. Okay, so that's how you determine the sign, meaning positive and negative, of the trig function of any angle. Now let's look at how we determine the ratio. So if I said find the trig function, so sine, cosine, tangent, cosecant, secant, cotangent, of a special angle. So what's a special angle? A special angle is any of these angles here, or any angle that has one of these reference angles. So 0 or like 180. 180 would be a special angle. All right, 30 or 210. Since 210 has a reference angle of 30, that would be a special angle. 90, 270, 450. All those angles have reference angles of 90. All right. If it's not a special angle, you need a calculator or a trig table. But trig functions of special angles, here's how you're going to evaluate it. All right. First, determine the sign by looking at where the terminal side of your angle lies. All right. That'll tell you if your answer is going to be positive or negative. Then find the reference angle, and then the chart will tell you the ratio. Okay. So we're going to do a bunch of examples, but let's say we just had, let's think of one real quick randomly, like the sine of 210. Okay. Now 210 is in quadrant 3 because it's 180 plus 30, okay? So it's going to be negative because ASTC, only tangent and cotangent would be positive of 210. Secant, sine, cosine, cosecant are negative because quadrant 3 is where tangent's positive. Alright, then I'm going to look at the sine of 30 because that's the reference angle of 210. Alright, and I get 1/2, which means that the sine of 210 will be negative 1/2. Okay? If I did the sine of 150, alright, that would be positive 1/2 because 150 is in quadrant 2, and that's where sine is positive. Alright, and it's the same reference angle as 30, so that's why these are going to equal each other. Okay? Let's try a couple more. Whoops. Alright, so now the cosine of negative 150. Alright, so negative 150 has a 30-degree reference angle, and it's in quadrant 3. So I should write this instead. Since it's in quadrant 3, we know that our answer is going to be negative. Alright? Then I'm going to look at the cosine of 30, and that is equal to root 3 over 2. So the cosine of 150 is going to be negative root 3 over 2. Okay? For the tangent of 3 pi over 4, so 3 pi over 4 is equivalent to 3/4 of 180. So that's 135 degrees. Okay? 135 degrees is an angle in quadrant 2, so ASTC. It's in quadrant 2, so since only sine is positive in quadrant 2, tangent's going to be negative. Alright, and it also has a 45-degree reference angle. So, since the tangent of 45 is 1, the tangent of the tangent of 135, or 3 pi over 4, is going to be negative 1. Alright?